200. I am asking Australia from the CA section. Very roll number is 24B21040. Today my topic is about introduction to probability distribution functions. The definition of probability distribution function is known as it is a fundamental tool in statistics. It visually represents how probabilities are distributed across all possible outcomes of a random variable. The another definition of probability distribution function is it is a function that shows how probabilities are distributed over the possible values of a random variable. It also tells us the probability that random variable takes a value less than or equal to a random variable. It is denoted by capital Fx of x equals to p of capital X less than or equal to x, where capital X is a random variable and small x is a real number. Capital Fx of x equals to probability that x is less than or equal to small x. And it is also used to understand the probabilities behaviors of a random variables. It also calculates and cumulates of the probabilities. So the likely is that the outcomes fall within certain ranges, where can be also used in probability theory and statistics in engineering for analysis signal behaviors and in data science for modeling uncertainties. There are two types of random variables. In that first one is discrete random variable. A discrete random variable is one that only takes a specific portable value. These values are often integers, meaning that these are gaps between possible outcomes. We can list them one by one. The another definition of discrete random variable is a variable that takes specific uncountable values like 0, 1, 2, 3. For example, the number of hits when tossing 3 coins, number of students present in class, and the distribution function. And a distribution function is a cumulative sum of all possible values of x up to x, small x. Since x is a discrete, f(x) of x takes the form of a staircase, it increases in steps. Another example of discrete random variable is number of defective items in a sample for a product two lines. Mathematical form of a discrete distribution function for a discrete random variable is capital F(x) of small x equals to summation I is equals to 1 to capital N p of xi into u of x minus xi, where p of xi is probability of capital X equal to xi and u of x minus x is a unit step function. Unit step function is defined where 1 for x greater than or equal to 0 and 0 for x less than 0. It is a function that helps in activating the probability values only if x greater than or equal to 0. For example, understanding discrete probability distribution function. For a discrete random variable, the probability distribution function often takes the form of table, a list, or a simple graph that assigns probability to each output. Let's say we toss 3 coins. The random variable x is number of heads. Let the value of x be x1 equals to 0, x2 equals to 1, x3 equals to x3, x4 equals to 3. And the outcomes are given as p of x, p of x1 for getting 0 heads. It is given by 1 by 8 equals 0.125 as given in the table. And p of x2 for getting 1 head. It is given as 0.375 is equals to 3 by 8, and probability of getting 2 heads. It is given by 3 by 8, 0.375. Probability of getting 3 heads. It is given by 1 by 8, 0.125. The cumulative sum of all these probabilities is equals to 1. The graph of discrete probability distribution function is unit step. And the second one is about continuous random variable. The definition of continuous random variable is a continuous random variable can take any value within a given range or interval. Like discrete variables, you cannot list all possible outcomes as there are infinite many. And another definition of continuous random variable is it is a distribution function. This it integrates sorry, it is the integration of continuous probabilities of x up to the value small x, and it can be defined as probability function of x, a continuous random variable. Then the distribution function of x denoted by capital Fx of x, and capital Fx of x equals to integration minus infinity to x small fx of x into dx. And the real world examples of height of an randomly selected student. Example 165.2 centimeters, 165.2 centimeters, etc. As given here, the time is taken. Time is takes for a commuter to travel to temperature in a room at any given moment. For understanding continuous PDF, for continuous variables, a PDF is written by a curve, and the probabilities of an outcome falling within a certain range is given by the area under this curve. The total area under the curve is equal to 0. For a continuous variable, the probability of it taking on any single specific value is essentially 0, as there are infinite possibilities. You only take probabilities for an interval. Graph of continuous random variable is given as under this curve is 1. The differences between discrete and continuous are discrete, discountable, and distinct values, where continuous infinite values in a range, and it is represented as uh, discrete is represented as bar graph, probability mass function, continuous plus probability distribution, and probability scale. P of x equals to x or greater than 0 for specific value of x, where continuous P of x equals to x equal to 0 for specific value of x, probability defined over intervals. Applications of probability distribution functions. Financial model. Predicting stock prices, assessing risks in investment portfolios, and quality control, ensuring product consistency, identifying defective batches, and another medical research and analyzing treatment effectives, understanding disease spread, weather forecasting, predicting rainfall amounts, temperature fluctuations, and PDFs are crucial in countless fields for making informed decisions under uncertainty. As where probability density function is used in stock market, where use ups and downs for, so, for an interval of time, and quality control for assuring that it is effective or it is good, and medical research. It analyzes how much the person is affected or how much the disease spread around his body or certain spot, and weather forecasting, predicting rainfall amounts and temperature fluctuations, so like climatic changes and further. Key takeaways or properties of probability distribution functions. Probability distribution functions are fundamental for understanding how probabilities are distributed across random variables, and discrete random variables have countable outcomes. Continuous variables have outcomes over a range. As discrete as distinct values, outcomes also will get countable. As continuous variables, there's infinite number or more, so outcomes also we get within over a range. The type of variable stacks how it is probability distribution defined in this slide. The specific probability distributions like normal distribution or binomial distribution. So that's all. Thank you for giving me this opportunity.